The main aim of our work in the CRACLab is to monitor air pollution as it evolves in real time. And the reason we do what we do is simple. Air pollution reduces our life expectancy. It's a killer. 500,000 people are estimated to die in Europe each year because of air pollution. That's 10 times as many as those who die in road accidents. We set up the CRACLab about 20 years ago. That's the Centre for Research into Atmospheric Chemistry. John Wenger and I decided that the health of the atmosphere had a direct effect on our own health. We monitor particulate matter, nitrogen dioxide and ozone in the atmosphere and try to pass on that information of the levels and the concentrations to the public as quickly as possible using our new real-time techniques.
What we're doing here is measuring the levels of nitrogen oxides. We know where these come from. They come from traffic and vehicle emissions. We see peaks in the mornings as people are going to work and peaks in the evenings as they're coming home. This data is important because nitrogen oxides are involved in the formation of ozone at ground level, which is a dangerous gas that can negatively impact human health. And it's therefore important that we share this information with the Environmental Protection Agency with the hope of improving air quality in Ireland.
We're developing state-of-the-art technology to identify and count both chemical and biological particles in the air. We get our results in seconds. That's quite different from the old traditional techniques in which you get results in days.
What we have here is a WIBS4 Plus, a wideband integrated bioaerosol sensor. And essentially what it looks at are things like pollen, fungal spores and bacteria, but it can do so at a very, very high resolution in milliseconds and seconds compared to traditional techniques which take days to weeks to analyze their data. Now this is very, very important for people who have health issues, people who suffer from asthma or hay fever, or indeed this could even be placed in a hospital to look at the air quality within the wards there. And this will allow people to mitigate their exposure to such particles and to live better lives.
The main sponsor of our work in the CRACLab is the Irish EPA. They've been supporting two main projects over the last 5 years. One is called Sapphire, which is run by John Wenger, which looks at solid fuel burning in small towns throughout Ireland.
So each individual fuel type or pollution source will have a unique fingerprint. So for instance, wood, which is burnt a lot in Ireland, contains a lot of potassium. So the spectrum will be dominated by the potassium peak at plus 39. So this instrument here is the ATOF-MS, or Aerosol Time of Flight Mass Spectrometer, and it is very much the crown jewel in the suite of instruments that we have here in the CRACLab. This instrument allows us to get to a level of detail which no other instrument can give us, and it has very much changed the way that we in the CRACLab analyse the air pollution in both Ireland and in places in Europe. The information we gather is then passed on to the Environmental Protection Agency and the Department of the Environment, and they in turn use this to craft new pieces of legislation or change existing policies with the single goal of cleaning up Ireland's air.
OLBAS has concentrated on the development of instrumentation to count bioaerosols like pollen and fungal spores in real time. Everyone has heard of the pollen count, and fungal spores can be quite toxic, both indoors and outdoors at composting sites.
This instrument here is called the Spore Watch. It's used to measure pollen grains and fungal spores in ambient air. The reason we're performing measurements at compost sites is because there has been a huge increase in industrial scale composting of green waste. This research is important because the more information we have on emissions from these sites provides us with a better understanding on how to mitigate health hazards.
About 3/4 of deaths due to air pollution are due to cardiac problems like heart failure and stroke, but about 1/4 of them are due to respiratory diseases. In Ireland, there are about 500,000 asthma sufferers out of a population of only about 5 million, and about 80 people die each year because of it here, and that's 80 too many. We have two main ambitions for the future. The first with the chemical particles is to turn our real-time measurements into real-time reporting to the public. And the second, with the biological particles, is to identify them in real time, not just count them. But if there's going to be a big issue, It really is the interaction between the chemical particles and the biological particles. We don't know what happens when diesel interacts with pollen, what effects they have, and so the measurements that we'll be making in the future will try to answer some of those questions.